Okay, welcome back again to this channel. Please, okay, it's always a great pleasure to come back with more new videos. All right, so now please, my name is Mtanda Samil and still we are proceeding with our marking guide of our UCE Aitel mock examinations. Please, we are getting some of the guides here such that we see the way forward. Please, you check in the playlist. We have right there from item 1, item 2 up to right where we are on item 3. Okay, good. So please, we kindly request you to always comment. All right, the comment may be, you never know, somewhere things may not have gone well, like say for example there may be an error in there may be a typing error somewhere. Well, I may not necessarily see that, but for you as you're watching the video you may see it. Please, you always have that written in the comment section such that we get your way on how we can get that improved upon. Okay, so let's again continue. Okay, now I got some issue that is, some people have issues with subscribing. I don't know, but I think I'll have a video on that, on how we can get that done. Okay, let's move. All right, good. So we kindly call you to subscribe to the channel. All right, then also not forgetting, you must share, okay, like, and of course you comment. I've talked about that alone. Okay, so without wasting time, I think let's get there and we get set with this. Okay, please, a simple reminder, we are dealing with Aitel mock examinations paper and we're having it. Okay, we're just making some bit of revision. Okay, we say, now the thing, one of the most misunderstood branches of physics for many years has been space physics. Now, space physics is simply, we call it astronomy. Some of the examples such as misunderstandings, some of the examples of such misunderstandings include the following. The Catholic Church at one time thought that other heavenly bodies, including the sun, orbited around the earth. Now, to orbit means to move, like you look at this cursor. Okay, maybe in order for us to understand the word orbit means, okay, assuming I have my circle right there, then orbiting means this. To orbit means this. Now you see that cursor of mine. Now what I'm doing there, I'm orbiting that circle. I'm orbiting that circle. I'm orbiting the circle. That's what we mean by orbiting. That's what we mean by orbiting. I'm orbiting that circle. So whenever you see the word orbit, just know that's what the meaning. Okay, I think with that let's proceed. Okay, good. Heavenly bodies, including the sun, orbited around the earth. That now here they're trying to say that instead it is the sun which orbits around the earth anyway, rather than the earth. But of course we all know that it is this earth which orbits around the sun. So the earth is the one which moves, the sun is just in one place. Good. This was the problem that Catholic hierarchy had with Galileo. Now Galileo was also a scientist. Now please, I may not pronounce these names like the way you may have them pronounced, but of course hoping you really understand what you are dealing with. Still remains the same person. So I'll read it as Galileo. I don't know how you read it. So for example, the church tried and arrested Galileo Galilei for supporting sun-centered view of the universe. By the way, if you didn't know, back in the early 19 there, of course we're in the 2000s. Now back in the early 19s, the Catholic Church was the strongest. Of course, strength in terms of money, like they had money to sponsor some of the activities, like say for example in science experiments, carrying out different things. So with them, they took it that it is the sun which was moving around the earth. Now when Galileo came up with some other observation in contrary to the Catholic Church, it was going to be a big shame, of course. So this guy was had, in fact they even arrested him over that, but of course had to produce proof. Okay, proving, because for him he was saying that the sun is at the center, is the centered view of the universe, meaning that the sun is at the center of the universe. However, he was not also right. This is not also correct. They arrested him for nothing actually, because it is not that the sun is at the center of the universe, not really, but we can say that the sun is at the center of the solar system anyway. So we say, they're saying, while watching the World Cup, anyway, this is something different. While watching the World Cup, which took place in Brazil in 2014 at 9 p.m., that was night, East African time, the football fans watching the game in East Africa realized that it was still daytime in Brazil. Oh, That's a bit wonderful. But of course, we already see that some of them were puzzled. Of course, puzzled means confused. Puzzled by this. Okay. While it snows in bracket winter in most European countries in December around Christmas season, the people in East Africa have never seen a snowfall. By the way, have never. But of course, please, just to remind you, some countries in Africa undergo or receive snow, especially some parts of South Africa experience a bit of snow for those who have ever gone there anyway. Alright, so in East Africa, and some of them wondered why it is this way. Now, here you must note out some of the few things here. I'll make an underlining. So we are talking about snow. That's part of the question. Then another thing, we are talking about watching a World Cup. It means that they have a different time. I think the time in Brazil is different from that. The time in Brazil is different from that in East Africa. You can really see that. Okay, good. Then also here, what are these people talking about? These people are discussing about the universe, the Galileo and the Catholic Church saga. You realize that they're talking about the universe. In fact, that all brings us back to what we call the space physics, or in simple terms, we have termed it as okay. We have termed it as astronomy. Okay, now with that, let's go and see what next. So let's see after hearing all that. Now, of course, we have the pictures for you here. You realize that this is our Earth. Okay, you see that the other side it is night, this side is during the day. Anyway, some good pictures, I think, a bit enticing. So part A, rather task. As a learner of physics, write a report to the community on enlightenment about these astronomical events in order to promote deeper understanding of physics in the school and community at large. Now, of course, you really see that they want us to make a write-up or a report. The report we shall make sure based on these things here. Please look, talk about winter, talk about different time zones in different places, though here there is in Brazil and East Africa. Talk about other astronomical phenomena up in the air. Of course, we should have by the end of the day a say about the Catholic Church versus Galileo's issues and that case. Anyway, that's what we're going to do. Now, to begin with, we're going to begin with this part, talking about astronomy. What does astronomy really mean to you? I think without wasting time, let's get there. What does astronomy mean to you in simple terms? Now, let's get this here. You realize that we're going to use these pictures here to know. Of course, just look at how beautiful these ones are. Look at them. Now we really see that here. This is the picture taken up in the sky. Now I think those small things, small and lighting up. Of course, you know that those are simply what? Stars. Now, where do they come from? Of course, just imagine, like those people who were there around in 1910. What do you think they were thinking about the universe? Like when you look up in the air, just take a quick glance up in the air at night maybe. What do you see there? You will see, of course, the stars, you will see the moon, like that. Where do they come from? And of course, that is when we are at night. What about during the day? What will you see? During the day, you will see the sun. You see that? So, you will see the sun. Now, it means that we must think about at what we see on top, like this, when you're on Earth, but outside the Earth, something else exists. Like, we have the Earth here. The Earth is the center of the solar system. And the solar system is right here, the Earth. And these are planets. Please, in one of the videos, we have a video explaining how planets and satellites operate. So these are all planets. Of course, you all know that we have very many planets. We have planet Mars. We have planet Mercury. We have planet Earth. Like that. So these planets here, and what they do here, they orbit around the sun. Allow me this. Now they orbit around the sun, and what happens here is that, look, now let's take for example this one here, or this. It will move in this circle like that, comes back, moves, comes back like that. Now what I'm doing here is simply I'm orbiting the sun. So the sun is just in one place. Now this Earth orbits, even this planet orbits. Please, there is a video in the playlist there. I'm forgetting the item number, but okay, I'm going to attach for you here that video talking about the universe and so on, the satellites, more information about this. I'll be putting it for you at the end. At the end of this video, it will come. It will be a pop-up there, such that you also have it watched. Now, that's what I mean by the universe. And now let's go and see how that it is in writing. Let's go there. Okay, let's see that in writing. So now we're saying that we say that astronomy is the scientific study of celestial objects. Now, okay, celestial objects, this means that celestial objects mean more like floating. I don't know how I can explain this, but the simple terminology I can use is floating bodies. The celestial means floating bodies, automatically floating. Of course, you know that there is the floating when we have water. That floating means that water is supporting, but this one here are heavenly bodies. Celestial may mean heavenly bodies, more like bodies up in the sky but moving on their own without any support from anything. Okay, now what does it mean? Now, okay, celestial objects, space and the universe. So astronomy simply means that studying about those objects which rotate up in the space, okay, and the universe as a whole. All right, now of course the question comes, is there a difference between a universe and solar system? We shall come to see that. Now we are saying, what do we have in the space there, or what does astronomy tell us more? It involves the study of stars, galaxies. Now galaxies is a group of stars, planets and asteroids. Now asteroids, of course, I know it is more like a myth, I don't know, but I'll talk about it as a myth. Now asteroids are more, I know you have all ever heard of the issues, the stories, the rumors which circulated that there's a big stone up there in the space that will soon come and hit the earth, and guess what, it will be really hot fire if it hits the, of course when it hits the earth, guess what next, we shall all just die. There's that myth there, especially in some radio stations, some radio presenters, please, they talk about those big stones. Now those big stones, we call them asteroids. Okay, and the specific talks about, now cosmology deals with, cosmology deals with the satellites, if you can really see that, satellites, and the astronauts. Cosmology deals with the astronauts, like those who go at the moon, you really see that. And it is in this story that now we look at what we call the America moon landing, which happened in USA, in fact. Yes, okay. The Americans claim that they went to the moon, really, that they went to the moon some time back in the days, which I, for one, I don't want to mention because the video may be put down. I have that, I'm putting it for you. Just know I have that, and just space not enough, but I have over 100 of them. I don't want to mention because my video may be taken down, but just know the American moon landing, no, it was that. I don't want to talk, but you really see what that means. Okay, now that's I think proceed now. Space and cosmology and space exploration, of course, that's what astronomy talks about. The sun is not considered to be at the center of the universe. Yeah, I talked about that. The sun is not at the center of the universe, but it is at the center of the solar system. Please, I've showed you what a solar system is. Solar system is this thing you're seeing here. A solar system is what you're seeing here. Sun in the middle, surrounded by planets, different planets. That's what we call a solar system. So sun is the center of the solar system, not the universe as assumed. Now, of course, where do we get this evidence from? So center of the solar system, orbiting around it. So orbiting around it, and the solar system, you have sun in the middle and other planets. So other planets orbit around the sun. I've explained what orbit means. Now the idea was proposed by Galileo Galilei's observations and Isaac Newton's laws of motion and universal gravitation. Now remember, with Galileo, with him, he said that the earth is the center of the universe. Well, he was close to that, so we really thank him for what he did. But Isaac Newton nailed it hard and made it more proper. How? Isaac Newton gave us the law of gravitation, which says that on earth, in fact, the law of gravitation, of course, you really see that. Okay, you find that if you have, this is the earth surface, and imagine you're holding maybe, say for example, an apple. This is our apple. You're holding it up in the air. Then you suddenly release it. What will happen? This apple will come and fall down. You see that? So we shall have our apple right on the ground right there, like that. So if the apple falls from here down, what does it mean? It means that there's a force of gravity pulling it. Now what does it mean? The apple has a certain mass, mg, and even the surface, of course the surface also has a certain mass. I will call it capital M, but just so that the mass of the surface, capital M, is greater than the mass of the apple. So this one is the mass of the surface, this one is the mass of the apple. Now, with Newton came and said that the law of gravitation says that if two bodies have masses, then there exists a force of what? A force of attraction. And that force of attraction, you call it gravitational force. And now, a body with a greater mass tends to pull a body with a lesser mass towards itself. That's why this apple falls down. Do you really see that? Okay, very good. Now, what does it mean? If you have, I'll take you back still to the solar system here. If you have this, what does it mean? If you have this, since the sun is in the middle, and the sun is more heavy compared to the other planets, now why are they rotating? They are rotating because this sun tries to pull them to itself, and meanwhile, remember, this planet also is acting against this. Do you see that? Since this planet has mass and even has mass, there's a force of attraction between this planet and that planet. There's a force of attraction between this planet and that sun. Now, in so doing, since there are those gravitational forces acting on this planet, the planet will be kept to be moving in a certain ring, which we call an orbit. Oh, that really makes some sense anyway. Okay, it becomes hard to explain this without having some of these pictures with us here. Now, still again, we want to talk about something else. Remember in the question, we had very many things. Now we have talked about astronomy. What about, did you know, or anyway, what about the time differences? Like, why is Brazil having some other time differences compared to East Africa? Like, those people watching football at around 9 p.m. in East Africa, which is night, but in Brazil, where the match was being cast from, was it was a daytime right there. Okay, now this starts with, let's get there. Now, to understand what that means, let's get here. Still again, we shall go back here. Okay, now we have the subheading time differences in different places. Allow me just use that, time differences in different places. Okay, it all begins with this. Now what you must know is that we begin from here. Now these are all different places. Now are you seeing that here, this side here it is night. Okay, here, this side here it is night, and this side here it is day. Please, I want us to understand this. Now, why is this one night and this one is day? When the sun is this side, of course this one will be there, brighter, and the other side will be in the shadow. And that shadow is what we call a night. Of course, you all know when you're standing under sunshine, you will have a shadow cast on the ground. So that shadow take it to be night when the sun is hitting one part of the earth, and the other side will be night. And that's why, now look, we have this. This is 12 p.m. This is 12 a.m. We have this at 6 a.m. We have this at 6 p.m. I think now it means that the time differences will be in this way. That, look, what if when here, maybe this one is our, I'm just giving an example. This is our Brazil, and this is where our East Africa is. I think that there's a difference in time, yet we are all on Earth. If you can really see that. However, now this comes with a lot of interesting theories again. Now, how does, of course, here now, what I'm talking about is, you must now come and know the rotation of the Earth. How does the Earth rotate? Now, here we go. Now, the Earth rotates about the equator. The Earth rotates about the equator. Just imagine you having a ring like that, like the equator, and the Earth is rotating just right on that. Now, what does it mean? The Earth rotates in that way. Assuming, maybe, okay, the rest of this, assuming now we have maybe our rotation axis, that is our rotation axis of rotation like that, and the Earth is moving in that order. Okay, the Earth is moving in that order. You all know, I hope you understand, going that side, then again coming over this side. I hope you can now imagine that kind of rotation. So the Earth's rotation also may affect this. Now, what you should know is that when the Earth is rotating, now we must connect the Earth's rotation with the time. Now, the Earth rotates at 15 degrees per hour, meaning that every hour which goes, means the Earth has rotated 15 degrees. I don't know that you can really see that. The Earth has rotated 15 degrees. Now, please just imagine if you are facing this direction, then you rotate facing this direction. That implies you have turned it to 90 degrees. Then you rotate facing this direction, it means you have turned it to 70 degrees. And you rotate facing this direction, like that. Maybe that will be 360. Okay. Now, okay, maybe this one is 0, this one 90. No, this one is 180. This one here is 270, and 360 comes back in that very position. I hope you can really see that. Now, those kind of rotations are the ones you're going to use here. Now, as the Earth is rotating, every 15 degrees means an hour, of course, on Earth. Now, so every hour which goes on Earth, just know the Earth has rotated for 15 degrees. And how does it mean? It means that when you get the 15, okay, the 15, like that, times now 24 hours. Of course, how many degrees will the Earth have moved? The 15 times the 24 hours. You guys that multiply 15 times 24. Okay. When you multiply 15 times 24, you'll have, I think, you try it also and we see the way forward. Times 24. Alright. Realize that when you multiply 15 times 24 hours we have in a day, it means that remember 15 is in every hour. It means that the Earth will have rotated at 360 degrees. And 360 degrees means a complete rotation, meaning that the Earth rotates, makes a full revolution in 24 hours, and 24 hours means 360 degrees. And we have this. After 24 hours, the Earth has completed a 360 degrees resolution. Now, if you have known that, of course, don't forget this, 15 degrees, 1 hour. You must put that into account. Now, what does it mean? Now, we must now come and talk about the lines of longitudes. The lines of longitude mark. The lines of longitude mark the hours in each day. Now, what does it mean? Okay, I'll still put for a display here. Of course, you are really seeing those small lines which are in there. Those small lines which are like that. Those small lines which are like that. Those small lines like that. Those small lines. There are very many. In fact, I can't complete all of them. There are very many. Now, I want to ask, what if when every line here has 15? Like, say for example, if from here, we have, I'm just giving an example, 15, you have 30, here we have 45, here we have, okay, add 15 here, we shall have 60, here we have 75. Are you really seeing that? It means that from here up to here, how many hours will have elapsed? How many hours? Let's count. This is 1 hour. Now, if it means that, if this displays X, and maybe it is 1 p.m. in this point here, what does it mean? Remember, every line you see there 15 degrees. By 15 degrees meaning 1 hour. So, if you move from here to here, that will be 2 p.m. From here to here, that will be 3 p.m. From here to here, that will be 4 p.m. From here to here, that will be 5 p.m. Now, if this is maybe East Africa, and this is Brazil, you see the time difference. So, the longitudes, as the Earth is rotating, every longitude has got an hour it represents. Hope that really makes some sense. We are moving in bits so that you can all understand this now. Do you see these white lines? Like, say for example, from here up to here means 1 hour. From here up to here means 1 hour. From here up to here means 1 hour. They have been symmetrically distributed in a way that, and remember, every line which here has a place it is pointing at. Every line here has a place it is pointing at. That really explains why we have different time intervals. Then we are saying that these also mark the time zones of the Earth. Yeah, of course. They will mark the time zones of the Earth. Now, what does it mean? It means that, like I've sure told you that from here up to here, 1 hour. From here up to here, another hour. It means that if this is Uganda and this is Brazil, of course, there will be a different time intervals. Like, say, if this is at around 1 p.m., 1 hour, that will be 2 p.m., another hour, that will be 3 p.m. Are you seeing the difference in time intervals? I hope that really makes some sense. So, the Earth's rotation, which brings about the longitudes. The longitudes, we have the equator, the Tropic of Cancer, the Tropic of Capricorn. Anyway, that's about the geography issue. But for you must take it as simple. For you must take it as simple what? Okay, get this here. Okay, for you must take it as simple as alright. The line is there which got right now from the center. Just imagine you having a circle like that, then you have lines generating from it, but every line means 1 hour or 15 degrees. That's what we simply mean. Okay, now remember we are on the other part of why we have different time intervals in different areas. In this question in particular, they use the Uganda versus Brazil. Okay, now what we have had there is a general explanation. Let's go and look at this in details again. Earth's rotation affecting, okay, this is why seasons change. All right, good. So very good. So with that, I think let's proceed. All right, so let's go and see this. Okay, let's go look at this. Oh, you have this in too. Click on this. Right, good. Feel like we have this in too. Let's get there, please. We get this done. Okay, again, I'll have this explained still. Anyway, here I think we are still explaining why time is always different in certain areas. And so please here, you discard this. It is not about seasons. You discard this. You discard it. We are still talking about why the season is why we have different time intervals. So you discard that one up. Now still again I was explaining. So since you have known that every grid line from here, since you have known that every line means an hour, like from here, every line, longitude line means an hour. Therefore, let's come back to this and get this done. Why is the time different? Why do we have different time intervals? Okay, good. Now, of course, I've explained. You know now how this means. Now, it means that here you really see that these lines, that is okay, longitudes, lines of longitudes. Now, realize that, but of course, before we reach that, we have these small ones here which affect different hours, and this one is pointing in a different place, this one is pointing in a different place, this one is pointing in a different place, this one is pointing in a different place. Now, what's the time duration from here up to here? If you really see, what is the time duration there? How many hours around there? Around 6 hours. So 6 times 15. How many degrees would the Earth have rotated? 6 times 15. If you try to get that done, you find that if 6 times 15, you'll have 90 degrees. So every 90 degrees, it means 90 degrees in the Earth rotation means 6 hours. If you can really see that. Now, that brings us back to this map of ours. Now look, I don't know how I can zoom it, but just imagine that from here up to here is equivalent to 15 degrees, and still from here up to there is equivalent to 1 hour. Now look, where is Africa? Africa is here. And where do we have Brazil? Anyway, where do we have Brazil? Now Brazil is around here. If you can really see, Brazil is around here. So it means that if you really see, every line here means a different time interval. Like say for example, if it is 9 here, like this, now here I'm moving backward. So minus 1 hour, minus 1 hour, minus 1 hour, minus 1 hour, up to when you reach Brazil. You find that Brazil will have a different time interval indeed. As it will be night time in Africa or East Africa, then it will be daytime in Brazil. Hope that really makes some sense. Now that brings us to what we call the West and the East. Now, if you are on this, like say for example, if you have to start from, of course you're talking about Brazil. If you try to put a line here between Brazil and Africa, it means that this side here it will be our eastern direction, and this side here will be our west. Now they are saying traveling west, time gets earlier, meaning that when you go to the west, they mean that Brazil is ahead. Earlier means ahead. Of course, they will be ahead of us. Then as you're traveling, meaning that as you're moving, from Africa coming this side where the marches were in Brazil, the time will be earlier. Meaning that for them, as it is a day, say for example, maybe say for example it is 12th of September 2025. I'm just giving an example. It's 12th September 2025. This, it will be day in Brazil. Meanwhile, the same date, it will be night in East Africa. That's what you're meaning. that Brazil is ahead of us. Oh, sorry. Okay, yeah. No, okay. No, maybe this one will be 12 now on the 13th. Okay, on 11th. Now here it will be 11th of September 2025. Are you seeing? 11th. Now as on 12th it is a day in Brazil. Here we shall be in 11th. On 11th, that day on 11th September at night, as we are moving towards the 12th where Brazil is. So Brazil will be ahead of us. Now, still, this is different, please. This is different. This goes with this, like this. This also is separate. It goes like that. Now, what does it mean? As we are moving towards the east, the time gets later, meaning that for us we are behind. We are behind. Now, it means that as you're moving towards the western part of the universe, the time gets later, meaning that Africa in particular, we are behind in terms of some hours. And okay, for all countries in this western part are behind compared to the countries, rather all countries in the eastern part are behind compared to the countries in the western part. Hope that really makes some sense. Let's move on. Now that really brings out to the Earth's rotation versus 15 degrees mean 1 hour, the 15 degrees back onto the longitude max, of which each longitude mark has 15 degrees, and you try to move away. Every longitude mark you move means an hour, and there are very many longitude marks from East Africa up to Brazil this side. So the difference in the longitude marks also, which are affected by the Earth's rotation, bring about the different in time zones. Let's go and get that answered. Okay, good. Let's have that written here. So we said Brazil is located in the Western Hemisphere primarily. Of course, Western, I've explained what that word West, Western Hemisphere. But now, let me comment on this. Some people may not know what the hemisphere means. Please, if this is our Earth like this, if we divide the Earth into this, like this will be the Eastern Hemisphere, and this will be the Western Hemisphere. You really see that? Now, Africa is in the Eastern Hemisphere, and Brazil is in the Western Hemisphere, if you can really see that. The word hemi means a half. Hemi, then sphere. Remember, the Earth is a sphere, so hemi means a half. Just like we know, we have what you call a semicircle. So hemisphere means halfway. So Brazil is located in the Western Hemisphere, primarily in South America. Anyway, you may not specify this when you're writing your physics. You may not. Okay, anyway, this is simple. Primarily in South American continent, and spans across 4 time zones. Meaning that you realize that from Brazil, I'll explain this here. You really see that from here. Like from Brazil, you see that Brazil is here. But we have this grid line moving. That's a different time. Still, even in Brazil, the time is not always the same in some places. So you see that we have this line here. We have this line coming down to that. We have another line coming down. Still in Brazil, you have another line coming like that. And every line means a different time interval. So it means that to be a different time here in this place and a different time here in this place. Still in that very Brazil. So it means that it's kind of big. That's what I'm meaning here. So it spans around 4 time zones. Trying to underline it. 4 time zones I've explained. Every line you see that this means a different time zone. Every line you see in the map of Brazil means a different time zone. So a place at this line, longitude line, and this one here will be at different time intervals. Okay. East Africa is located in Eastern Hemisphere. I've explained that. Primarily in Africa. Okay, Africa continent. Okay, this just came about anyway. And it spans across several time zones. Yeah, just like we're in Africa. Still again, we also have different time zones. Of course, I've explained every grid line you see moving around. Maybe this grid line is in South Africa, and this grid line is in Uganda. So they don't be at the same time still again. So Brazil is west of the prime meridian, 0 degrees longitude, while East Africa is east of it. So each hour represents 15 degrees difference in the longitude. I've explained that fully. And what that really means in simple terms. Now again, remember, we have talked about the Earth and the space physics. Now here we've talked about the difference in time zones. But again, what do you think brings about what we call the winter seasons, and what brings about the summer seasons. Still again, let's go there. But before we finish this, please realize that when you go in the playlist, we have a physics. Okay, we have physics of last year, UNEP 2024, and the item 1. Was it item 1? Item 2 was talking about some of the things here. So you have it watched also, such that, in fact, I'll make a pop-up of those 2 videos here. I told you of there's a scenario which was talking about space physics, then that UNEP paper of last year, as presented in a video format. I'll have it here at the end of this video. Now with that, let's go and see. But again, if you have seen different how time changes, we must go and see how the seasons are affected. That begins with this guy right here. Okay, why seasons change? Let's begin with that. Now I want to know why do seasons change? In this context, we want to look at why do seasons change. It all begins with this. Now still, the rotation of the earth brings about this. I don't know whether we can really make a follow up here. Now the rotation of the earth brings this. Now of course, you all know that from the pictures we had earlier on, this is our what? Our sun. And this is the earth. And the earth is orbiting, allow me to use this. The earth is orbiting the sun in that order. The earth is orbiting the sun in that order. The earth is orbiting the sun in that order. And now guess what? As the earth is orbiting or rotating around the sun, what must you know? What must you know? Now, as that is happening, it means that as the earth is around in this place, the sun rays will come directly like that, and that closes that. So we have again this picture from here like this. What must you know? As our sun is here, the rays from the sun will come and hit. But remember, this is the point of rotation of the earth. The earth just rotates. In fact, the kind of rotation here is that I put for you this. This thing here is used by kids when they are playing. They hold it up here and they make that thing rotate at each sharpest point there. Now the point of rotation here is that this will only rotate. This will only rotate. Now the kind of rotation of the earth, just imagine you have a piece of paper like this. Then you place a compass or a pen in the middle here. Then you try to move this piece of paper. You find that this point will move like this, but meanwhile the point of rotation remains the same, meaning that as the earth is moving, it only moves in this order. In fact, it doesn't leave this point of rotation. So as it means that this side of the earth receives sun rays. Do you see that? That side of the earth I'm shading receives the sun rays, while this side here does not receive. Now what does it mean? It means that the earth cannot flash or give light to the earth, the whole of it. That cannot really happen. So it means that on one part it receives the light and the other receives a shadow. That shadow means night. That light means during the day. Okay, very good. Now, what does it mean? But now this drawings I put them for you is that you see this object here can rotate at its sharpest point here, but still the rotation will be like this, like that, where the point of rotation will still be the same. Or you have all ever seen these things here in the offices. You can see that it's more like a globe but made of more like a balloon. They make a globe in shape of a balloon. You ever seen that? I think. Now the way you move that globe onto that point of rotation, the axis of rotation doesn't change, but it is the balloon or that ball which will move. That's what I'm trying to mean here. Now what does it mean? So you have known that the earth flashes this side, and since this one is dividing it in the middle, this side will be during the day, and the other side not receiving the sun directly will be the night. Now we have explained why the nights happen, why do you have day and night always. That aside, of course I've explained that. Now next again we come back to this. Now as the earth is rotating, the end of rotation is this one. It means that this side which you are calling it day in simple terms, you may also call it, since it is very hot, that point there will become what? Summer. Then the side which you are calling night, since it is wet and cold, it is one we shall call our winter. Hope you can really see that. Now the changes always happen in June and December. June and December, that's where the magic happens from. Now in December is when we have winter, but in which hemisphere? Anyway, let's go there. Now we look at this. If this is the earth axis of rotation like this, or the equator dividing the earth into two, this is the equator dividing the earth into two. But remember, the earth's point of rotation is this one. That's the Earth's point of rotation. So the equator is just right there. That's the equator. Now what does it mean? I think let me resolve this such that I can get this clearly. So this is the Earth's point of rotation, axis of rotation, and this is our equator. Now the sun rays come like this. I see. When the sun rays come, they will hit part of this side. You can really see that. They will hit this side here. And now this part here, we shall call it what? Now, as you're seeing this equator here, this side here, we call it the northern hemisphere. And this part down here, we call it the southern hemisphere. So it means that once you have the Earth like this, the equator divides it into the northern hemisphere and the southern hemisphere. If you can really see that. Now, here, the sun hits more in the southern hemisphere than in the northern hemisphere. Now, what does it mean? It means that this one which is receiving less light will be in winter season, like you can really see here, winter season. This one receiving more light will receive summer season. That always happens in December. So it means that in southern hemisphere, where we have America and Brazil and other countries, in December season they always experience winter. That is it. Now after 6 months, we now move to what? June. Now in June, it means that again, due to the Earth's rotation, the northern, remember here, due to the Earth's rotation, remember as the Earth has rotated, remember the sun is in one place and the Earth is orbiting it. Maybe it was around here and they're hitting. Allow me call this. Maybe here the Earth was hitting. Allow me call this as our Earth is like this. This is our point A and our point B. Now as the Earth is at this point, it means that this is our point A and this is our point B. You see that? Now when the Earth moves in this position here, like it is, they change. The one who was inside goes outside. So this is our point A and this is our point B. Here it means that the rays are hitting point B, if you can see that. When the Earth moves up around here, it means that now it changes. The rays are now hitting point A. I hope you now will know how the Earth spins. Now, if you really look at this, this is our point A and our point B. Now, as the Earth moves from here up to around there, is what we have here. It means that here we have now our point B and our point A is this side, in the dark region, if you can really see that. Now, it means that still, the northern hemisphere will be receiving more light. Because this part is a bit down, so the northern hemisphere will be receiving more light, therefore will be in the summer season, and the southern hemisphere, just see, a little area, in fact, more like they want to just, some of the rays just go astray, you see that? While here they are hitting it harder. Now you see that, here what you must know is that, in December, winter, then what must you know? In December, if it is winter, then the southern hemisphere will be affected. For us in Africa, we are at this equator and part of the northern hemisphere. So here, when it has changed, part B is now receiving. Now it means that here, this one has less sunlight, therefore shall be in winter in the southern hemisphere. Meanwhile, in the northern hemisphere, we shall be in summer. Summer means dry season and winter means wet season in Africa. Here, if you make those comparisons right there, and I think that makes some bit of sense. We are winding up with this anyway. Now, so that brings that about. But again, someone will ask, what about the equator? What happens? Why is it that East Africa, we don't experience winter? Just know that in all phases, look at this. I'll rub off this first of all. Are you seeing that the equator is here? It means that there are some sun rays reaching the equator right there. So the equator in December, still, if some sun rays are reaching the equator, it means that it will still be a dry season. If not like dry, but moderate, balanced. So what about here again? When the sun is hitting this side, this was A and this was B. After rotation, this becomes B, receiving the sunlight, and the A is in the dark region on the other side. So still again, the equator in either way, since the equator is midway, the point of reach of the sun rays, it means that still the equator receives the sun rays in either way. That's why in Africa you have equal days and nights in some days of the year. And now, so the equator receives sunlight, and we have that explained here. And now, all areas where the equator passes, we call them the tropical regions. You will see that the sun is here, but in all cases, the sun hits part of this and part of the equator heated. From here, the sun hits this and part of the equator heated. In all cases, even when the earth has rotated in each angle, the equator has to be heated. Meaning that East Africa, which is, of course, the equator passes through Uganda. So, if Uganda is near the equator. It can never experience winter. In fact, the regions at the far ends, this side, are the ones which experience winter, like that. At the extreme ends of the pole of the earth, experience winter. So this area can experience winter, this area can experience winter. Okay, anyway, that's what we're trying to mean right here. So with that, let's see this. All right, good. So we have this. Finally, now, like, do you see this? Now this is the sun. When the sun is hitting at this level, now this sun is the equator. I think the equator again receives sunlight. Again, when the sun is hitting from this angle, again the equator receives the sunlight. No winter. From this angle, the equator receives some sunlight. Now, I think then also here, when the sun is hitting, the equator receives some sunlight. It means that the equator in all angles receives some sunlight. Then, of course, we have been talking about the June and December. In December, just know it is winter in southern hemisphere. Now the opposite is true. Then in June, it is summer in southern hemisphere. Then again, northern hemisphere, it is winter in June. Then cross over the other side, opposite, it will be in the northern hemisphere, it will be summer. Okay, so it means that in December, countries like America are always in winter season. So the areas at this point and this point are receive what we call winter interchangeably. Like in December, south is in winter. Rather, yes, south is in winter. And okay, which one? Okay, the northern is in summer, like that. And I think that will make some sense, like that. I'm not bother explaining other things, like I have September and March. This is what we call an equinox. Anyway, that video which I'm going to post for you here will give you more details about this. However, as far as this item is concerned, that's how far I can go with it. Maybe you can see this in writing and see the way forward. Let's go there and see this in writing. Okay, so let's see this in writing. Now here talking about latitudes. All right, let's get this explained. Okay, good. Now you're saying that okay, latitude Europe is located at a higher latitude between 37 degrees and 70 degrees. Now, for you may not specify this, you may not really specify some of these angles because you may not know them. Then most of the African countries, which is between 0 degrees and 30 degrees. Now, you may not really take that from this to this. You may not really memorize that as a student. So, higher latitudes receive less direct sunlight, leading to cold temperatures. I think that, okay. Now, okay, about that, okay, you may not go with this, but start from here. So, the Earth's tilt or Earth rotation, the Earth's axis is tilted, causing the northern hemisphere to face away from the sun. I've explained this. Northern hemisphere face away from the sun. Then, during winter, resulting in colder temperatures. Okay, mountain ranges. Okay, in Europe have several. Of course, Europe has several mountain ranges, such as the Alps, which create rain shadow effect, leading to colder and dry conditions. Now here, like, apart from the Earth's tilt, even the mountain ranges can bring about the coldness, because they say the higher you go, the cooler it becomes. Okay, now the distance from the equator, of course, I told you that the equator in all cases receives sunlight, so the areas in the equator are always hot and wet, balanced. Now the distance from the equator, Africa is closer to the equator, receiving more direct sunlight throughout the year, resulting into warmer temperatures. So for you when you're writing your answers, please, I'll make some clarification for you here. You may not necessarily be able to remember all the other statements, but your answers can start just right from here. This is enough. The others, you may not have that memory of memorizing that, knowing that 35 degrees, not really an issue here. Okay, now with that, it comes to an end. Anyway, I don't know how you have seen this space physics. How is it? Is it an interesting one? Anyway, you leave a comment. Don't forget, I'm going to post a video here which will help you understand this more and more and more and more. Right, we are ending there. Nice time. Thank you.